Yeah, good morning, students. It's my pleasure to introduce about this classroom discussion topic on the sparse matrix representation. So now I would like to share my screen. Yeah, I hope my screen is visible to you. So the classroom discussion topic is sparse matrix representation. So summary of the previous classroom discussion topic is that we had a discussion on different types of searching techniques for searching an element in an array. So there are two different types of search techniques we discussed. That is, one is linear search and other one is the binary search. Fine. So linear search and binary search. This we discussed that. So in the binary search, what we are doing here is that we have an array of size 10, so which is indexed from 0 to 9. Then we want to search for an element 70. Then what we are doing here is that we are taking a left a index variable which is pointing to 0th index, and right is another index variable pointing to the last index. Then we are calculating the mid index by making use of this formula, left plus right by 2. So which we are going to get it as this is a mid index we are going to get. So once after we get this mid index, we are comparing the search element with the a of mid location element. So if the search element is equal to a of mid location element, then the search is successful. So if they are equal, then we are checking that the search is successful. Otherwise, if the search element is greater than the mid location element, then the search element may be present in the second half. Okay, so then we are moving this left to index variable from 0th index to mid plus 1. Otherwise, if this search element is lesser than this mid index element, then we are moving this right index variable to mid minus 1. Here we are moving to that. The element search element may be present in this left half of this array. So like this, we are dividing this array into half of that number of elements in the array, and we are performing the search. So that is what we had a discussion on that binary search technique. Now, in today's classroom discussion, the session objective is that how do we represent this sparse matrix using these arrays as well as this linked list representation. So that we are going to discuss. And the outcome of this particular session is that a student will able to represent the given array of matrix either using this arrays or linked list. Fine. So this is what we are going to discuss that. Now, the sparse matrix, what is meant by a sparse matrix? So first, a matrix which is having more number of zero elements than the number of non-zero elements. So, for example, if you have a matrix having a 3 by 3, for example, if you take, so total we have how many elements we have in this array of 3 by 3 size? So, we have totally 9 elements. So out of these 9 elements, so if the most of the elements are 0 elements, okay, so generally it is more than half of these elements are 0 elements, then it is called it as a sparse matrix. So why do we use this sparse matrix instead of a simple matrix? So that is storage. So there are less number of non-zero elements than the zeros. Thus lesser memory can be used to store only those non-zero elements. And computing time can be saved by locally designing a data structure traversing only non-zero elements. So these are the two reasons why we are using a sparse matrix representation separately. Okay, so for example, you consider this is a matrix having these elements. So for example, if you take this is a what is the size of this matrix? So we have 4 rows. So this is a 4 cross number of columns are 5 we have. So 4 cross 5 totally. Here we have 20 elements are there. Out of these 20 elements, we have only the non-zero elements are here 1, 2, 3, 4, 5, 6 are there. So out of these 20 elements, only the non-zero elements are 6. So here, if you represent or if you store this, we are going to wastage a lot of memory. We are going to wastage as we are storing only zeros. So what we are going to do here is that instead of storing zeros with the non-zero elements, we only store non-zero elements. We will store that. The remaining zero elements we won't store. So this means, how do we store these non-zero elements? So we will store these non-zero elements by making use of a triplets. So in which row and which column that non-zero element is there. So for example, if you take this 3, if you want to store or if you want to represent this 3, so what we are doing, so in 0th row, so in which column it is having, in column number 0, 1, 2, in column number 2, what is the value, non-zero value we have? So we have 3. So like this, we are taking these values, row, column, and the non-zero value we are taking as a triplet, and we are representing or we are storing all these non-zero values. So this is how we can represent this sparse matrix. So sparse matrix may be represented in two different ways. So one is array representation and another one is linked list representation. So we are going to see only the array representation, how it will be done. So a 2D array is used to represent a sparse matrix in which there are three columns which are named as the row index and the column index and as well as the value. So what is a non-zero value? So that we are going to represent and we are storing that. So for example, if you take here, so this is what we are going to do here. So this is a row index, 0th row, column 2, here the value is 3. So 0th row, column 4, the value is 4. So first row, column 2, the value is 5. So like this we can represent the sparse matrix. So this representation is called it as a array representation. So where we are taking these or we can take it as the 3 rows we are taking here, and the number of columns are is equal to the number of non-zero elements. So like this we can store that. This is a method 1. And coming to the method 2, which is called it as a linked list representation. In linked list, each node has 4 fields. So in linked list, each node we will take it as having 4 fields. These 4 fields are defined as the row. So in which row index the non-zero element is present, and the column index where the non-zero element is present, and the value of the non-zero element at that index, and then we are storing the next node address. So like this here, so we are in 0th row. For example, if you take here in 0th row, second column, the non-zero element is 3, and this is a link field pointing to the next non-zero element node. So this is what we are calling it as the node 1, representing the first non-zero element, and this is a node 2 representing the second non-zero element. So like this we are going to store the list of uh, non-zero elements in the form of a linked list. So this is what the linked list representation, row index, column index, and the non-zero value, and then the address of the next node. This is what the node structure we are taking. Fine. So we will use a program. How do we represent this sparse matrix using arrays? So for example, if you take here the sparse matrix of 4 comma 5, so 4 rows and 5 columns, and this is the matrix we have. So we are going to go represent this sparse matrix using a compact representation. That is what we are calling it as array representation. So if sparse matrix of I comma j, so here we have 4 rows and 5 columns are there. So we are taking a nested for loop here. So in that nested for loop, for I equal 0, I less than for I plus plus, for j equal 0, j less than 5j plus plus. And here we are comparing, if sparse matrix of I comma j is not equal to 0, then size plus plus, initially size is 0. So that we are taking we are counting how many number of non-zero elements are there. So in compact matrix representation, so we have 3 rows and then the size number of columns are there. Fine. So like this here we are going to represent, and this is a nested for loop we are writing for representing of this particular matrix, and then this is a loop we are using for displaying of this sparse matrix using arrays. So now the reflections part is, what are the advantages of sparse matrix representation? Fine. So if you are not able to answer this question, please watch the video from the beginning. So now the lecture outcomes are revisited here. After completion of this session, student will be able to represent the given sparse matrix using arrays as well as linked list representation. So the summary of the session is that sparse matrix can be used instead of a simple matrix for efficient storage and computing time can be saved, and sparse matrix can be represented by making use of arrays as well as linked list representations. Fine. So this is a lecture level practice problem. Convert the following matrix into sparse matrix representation. Okay, so it is very easy for you, and these are further references corresponding to this particular topic. Fine. So thank you very much.